Hey guys, this video is about absolute value equations. And so I wanted to start with just a little reminder of what absolute values are. The notation looks like the two kind of straight lines. And if I have the absolute value of, say, -7, you might remember from an earlier class that that's 7. Whatever you put in here comes out positive. So if I had the absolute value of 7, it would still just be 7. What that means on a number line, if this is 0, here's 7, here's -7. So the absolute value is saying it doesn't matter which direction, we're just saying it's going to be 7 units. So it's 7 units this way, 7 units that way. So the absolute value is referring to that distance right there of 7. We don't care that it was negative or the same distance this way, positive. So if I kind of generalize that, I can say the absolute value of x equals c. To figure out what this is, x is either going to equal c or x is going to equal -c. And so that's kind of what we're seeing here at the -7 and the 7. One kind of little tricky thing to this is we can't have an absolute value equal some negative number. And the reason is, if you think about, something like the absolute value of x equals -3, for instance. If I try to put 3 in here, it comes out +3. If I put -3 in here, it still comes out +3. So this is a no solution. Solution. That's when we see that, it's just a false statement, and so it's D and E. It does not exist on the computer, or no solution. Okay, so let me get to the regular problems. So this first one, we have the absolute value of x equals 5, and so absolute value equals a number. Everything's good. So all we have to do is say x equals 5 or x equals -5, because just the stuff inside equals the number, or the stuff inside has to equal the opposite of the number, because those are the two things that if I put them in would make it true. This next one's sneaky. It's a D and E. And the best way to spot that is right there. There's that absolute value of stuff equals something negative. So that one's a trick. You can solve it, you can get some answers, but if you check them, they end up not checking. It'll come out to this equals 7. Absolute value 7 won't make 7. So best place to catch it is to realize that can't happen. For number 3, this gets to be a little bit more real deal. So we have our basic idea that if we have the absolute value of x equals c, we're going to have, not absolute value, x equals c or x equals -c. So whatever in here gets set to this and its opposite. So for this one, which is quite a lot more complicated, instead of just an x, it's this whole lot of stuff. So that's going to go 2/3 x minus 1/3 equals +4, or 2/3 x minus 1/3 equals -4. And so now we have to solve out these two equations, which are the linears that we saw a couple sections back, and that's going to get us our two solutions. So I am going to clear the fractions, because this doesn't look that fun. So I'm going to do a 3 on both sides of this. If it helps to think of it as 3/1, that's cool. And same thing over here. So on this side, the 3's cancel. I have 2x. I distribute it here, so 3/3, that makes a 1, where the 3's canceled. And that equals 12. From there, I'll just bring this 1 over. I got 2x equals 12, and then divide both sides by 2. And it looks like x equals, 12 plus 1 is not 12. 12 plus 1 is 13. So then x equals 13/2. On this side, very similar math. So the 3's cancel, and I get 2x. 3's cancel, and I get 1. And then 3 times 4 makes -12. I'll add this 1 over. This time I'll really add it. And I get 2x equals -11. And then I can divide out the 2. And so x equals -11/2. So that one was pretty tough with the fractions. Some slightly friendlier ones coming up here. So these next 3 are ones that in a lecture section I would have you guys try. And so one of the things I would say on this one as I got you going is the first thing you want to do is isolate the absolute value. So this -13 here is not going to help. Because if I negate the 3, notice I'm not negating when I do this equals the positive, this equals the negative. I wouldn't get the sign change on that. So I want to make sure that I always isolate the absolute value first, and then proceed to splitting it up. So now this is 2x minus 5, and then equals, this is gone, and then it becomes positive 10. Also notice you might see that negative 3 over there and think it's going to be a no solution, but we got to get it finished off, we got to get it isolated before we can tell. So now that I'm here, that's cool. Now I can go to splitting it into the two equations. And then 2x minus 5 equals negative 10. And then I just solve each of these out. So I can add the 5 over. And get 2x equals 15. This time we get 2x equals negative 5. And then just divide the 2's over. And so I get x equals 15 halves and x equals negative 5 halves. Okay, so for number 5, we have a little simplifying we can do inside, and we have a little simplifying we can do outside. So I'm going to take a couple of steps to get this cleaned up a little. So we'll go 3x minus 6 plus 4. I'll just do plus 3 right now, 8. And then on this next line, I'll go ahead and get the 3 over and finish combining here. So then this is going to be 3x down 6 up 4, so minus 2 equals 5. And so it started off a little messy, but you can see I do a couple lines of work and I can get down to something a little bit easier to work on. So now I'll do the split it up. 3x minus 2 equals 5, or 3x minus 2 equals negative 5. And then we're right back down to the same two little solves that aren't too bad. So let's see, this is going to go 3x, that cancels, equals 7. And divide the 3 over. So that branch gives us 7/3. And then over here we'll go 3x, negative 5 plus 2 is going to be negative 3. Divide our 3 over. And then that branch simplified gives us negative 1. Okay, number 6, again with the fraction. So this one's already, simplified in that it's just absolute value equals a number. So we're kind of right here. 2/7 x minus 1 either equals 3 or same stuff equals negative 3. And for this, I would definitely bring those 1's over first, because then I can just do the reciprocal, so that's going to make it easier. So now I got 2/7 x, that cancels, equals 4. On this side I have 2/7 x, that cancels, equals negative 2. And then I'll just do 7 over 2 right there, and 7 over 2 right here. If it helps, you can throw a 1 down there. And I'll do the same thing on this side. So, cancel, and I got x. Let's see, this would be 28 over 2, which is 14. Or you can think 2 goes into 4 twice, times 7 is 14. Over here, those cancel out. 2's cancel, and I got x equals negative 7. Okay, so these next two are a little bit tricky. They are, so we have double absolute values. So, but it's the same idea. It's that either this stuff equals this stuff, or they're opposites. And so what I can do is I can say x minus 5 either equals x plus 2, or x minus 5 equals the negative of x plus 2. So the same way that we did this equals the positive or this equals the negative, we're still doing that. We're just doing it a little bit more algebraically. And then this one does a little bit of, this has a little bit of funkiness to it. So here, if I try to solve this, right, the first thing I'm going to do is bring this x over. And then look what happens. So this cancels and that cancels. I'm left with negative 5 equals 2, which, so that's a no solution. But that doesn't mean this is a no solution. That just means that this branch, it didn't give us anything. But if I try this side, I get x minus 5 equals negative x minus 2. So this side is going to work. And so here I get 2x and minus 5 equals, that cancels, and negative 2. Add the 5 over, and that'd be 2x equals 3, and then divide the 2. And x equals 3/2. So careful to not get where you see the no solution here and then don't finish out the problem. Most of these have 2 answers, like we just saw. Sometimes they do have just 1 answer. Yeah, so don't stop here. Keep looking for the other answer. This one is sort of the reverse of it. So if I do x minus 3 equals 3 minus x, and I'll sneak it down here, x minus 3 equals the negative of 3 minus x. So that would be the second equation. So if I go ahead and solve that, I get plus x, okay. And so that's going to be 2x minus 3 equals 3. I can add the 3 over, and I got 2x equals 6, divide, and x equals 3. Okay, so then I go to do the second one, and then this gets a little funky. So x minus 3 equals negative 3, minus a minus makes that a plus x. But then check it out, I got to bring the x over again. That drops out, and now I'm left with negative 3 equals negative 3. So what this means is it actually has infinite solutions. And so this one isn't terribly exciting because 3 is a part of infinite solutions. So here we got the no solution on this branch, but got 1 answer. Here I got 1 answer, but then the other branch said, yeah, this one's not that interesting because actually everything's an answer. So for this, you'd put down infinite solutions. And then this last one I would have you guys try. I'm going to clear the decimals right off the bat. And we've done some examples where we multiply both sides by 100 to clear those. And so I'm just going to take this thing and kind of rewrite it as 5 minus 5x equals 3 minus 7x. Because you can see if I set up my 2 equations, the next thing I would do is multiply by 100 on both sides. So I'm just kind of doing it at the start so I don't have to write it all out. And then we just, we set up the 2 equations and see where it goes. So 5 minus 5x equals 3 minus 7x, or 5 minus 5x equals the negative of 3 minus 7x. I could also negate this side. It's just kind of my habit to do it on the right-hand side because of the way the ones with the numbers run. So let's see. Let's bring the 7x over. And that gets me 5 plus 2x equals 3. Kick the 5 over there. And those cancel, and I got 2x equals negative 2. They can divide out. And it looks like this side is x equals negative 1. Do the same thing on the other side. Actually, let me distribute first. So 5 minus 5x equals negative 3. Minus a minus makes that a plus 7x. And so now I will subtract that 7x over. And I have 5, down 7, so minus 12x equals negative 3. I'm going to subtract the 5. Negative 12x equals negative 8. And then I'll divide the negative 12 from both sides. And so negative over negative would be positive. And then I'll reduce the fraction. This is 2 times 4. This is 3 times 4. Knock out those 4s. And this side gets us x equals 2/3. So even with the double ones, sometimes they'll still have 2 answers. Sometimes they have infinite answers or just 1. Cool. So that concludes absolute value equations.